the area of this thing is x times y. Do you have any disagreements with that? Okay, so this right here, we're trying to find the maximum area. Right now, in order for me to tell you what the area is, I have to provide you an x and a y. Then you can tell me area. But there's something real important that we have not worked with at all, and that's this 400 feet. Yes?
I have a question.
Yes?
I see that
1, 2, 3, 4, 5, 6
Do
X's.
they have to be 6 or you just came up with this?
Well, I said he wants to build these pens as shown. So when I say as shown, it was my original drawing, which had 5, 1, 2, 3, 4, 5 pens, which means we needed 6 of these pieces.
Okay,
So if this was drawn where it was only 3 pens, then you would have 4, right?
okay, makes sense.
Okay? So for this problem, it's going to be the way it's drawn. Okay, so area is what we don't want to find the maximum of. Unfortunately, to know area, we need to know 2 different things. That 400 is super important because the 400 is kind of like the total perimeter, so to speak. Even though perimeter is just the outside, the 400 feet is all the fence added up together. So let's talk about that perimeter. The perimeter is 400, right? Is the same as saying that 6x plus 2y's has to be 400, right? That was our 1, 2, 3, 4, 5, 6 x's plus the 2 y's. All of that added up together should be 400. Now, check this out. The area over here is not a function of x right now because it has a y in it, right? If I could somehow rewrite that y in terms of x, then area would depend only on x. But over here I have this condition. And since it has y in it, can't I solve this for y? Let's solve it for y. So I move this 6x over. I divide everything by 2. And that means y must be 200 minus 3x. Take that y and plug it back in here for this. And now your area is x times 200 minus 3x. Right? Y'all still there? So that means your area is 200x minus 3x squared, right? So now, does area depend on a single variable?
Yes.
Yes. So you could look at area as being a function of x, right? In fact, it is a continuous function of x. The area we could view as a continuous function of x is 200x minus 3x squared. So now you just tell me what x is. Was it 4? Was it 10? Was it 6? What was it? Tell me what x is, and this is going to spit out the area of the whole thing. I want to know the biggest this gets, right? What x makes this the biggest? There's only one more thing I need before I can do the calculus, and that's what? What method are we using here today? I started class, I split the board in 2. I said we have this and then we have this. This one was called the closed interval method. And they call it the closed interval because you have to have a closed interval. Okay? Do we have a closed interval? Right now I just gave you a function, right? We need to somehow see if there's a way we can restrict that x. So can we somehow get x to have to live between 2 things in order for this problem to work? Well, just look at the geometry of this. What's the smallest x could be? Nothing. I know it's ridiculous, you would never do it, but that would be the smallest it could be, right? X being 0, and then, you know, the farmer has officially gone crazy, right? Because he's building a pen, he's making one side nothing. But that is a lower bound, isn't it? That is a definite lower bound for x. The upper bound is a little bit tricky. Because most people say 400. But it can't be 400. Go back and look at this right here. Do you agree with me that y must be a positive number? Because y is the length of that side. So the worst y could be is if y was nothing. So what x would make this nothing? What x here would make this thing come out to be 0? What is it? Yeah, so you just set it up like an equation. You just go like this, move things over. So you could do like 3x equals 200, then divide 200 over 3. The way you can think about it is if this is 200 over 3, this is 200 over 3, this is 200 over 3, that's 200 over 3, that's 200 over 3, that's 200 over 3, well, then you've used up all 400 feet of your fence. And now you don't have anything left over to make a width out of. Does that make sense? But you can't say 400 just because that says 400, because you can't make that 400, 400, 400, 400, 400. You don't have enough fence to make even one. Yes? So this upper limit here is 200 over 3. There we go. We have a closed interval. So now we differentiate this. Do all the stuff we just did. Okay, step 1. What's the derivative of that function? A prime of x is 200 minus 6x, okay? Let's figure out when that derivative is 0. So that's an easy one to solve, right? So 6x equals 200. So x is 200 over 6. Right? We can reduce that, I guess. We'll make it 100 over 3, which is 33.33333, right? What do I need next? Is it ever undefined? Does the derivative ever not exist? There's your derivative. Where's your derivative? There's your derivative. Does that ever have any issues? No. So, no. Oh, was this in our interval? I didn't mention it because I knew it was, but you always have to check, is that in here? It is in there. 100 is within there. All right? So we have one critical number and we have our two endpoints. And that's it, right? So now we check them. And where are we going to put them? Our endpoints go into the original function, right? A of 0, A of, what was it? 200 over 3, and A of our critical number from over there, 100 over 3. Do y'all see that this is the same thing we've been doing, just with a word problem like that's framing it all? Okay, so these first two are going to be pretty obvious, I think. Like if you plug 0 in here, you get 0. And if you plug 200 over 3, what should you get? 0 again, because remember, that was me using up all the fence to build the x's and leaving nothing for the y's, so y would have to be 0. But you can check it for yourself. You plug that into there, you should get 0. But 100 thirds, that's not going to be 0. So let's see what happens here. Plug 100 thirds in there, we go 200 times 100 over 3, and then minus 3 times 100 over 3 squared, right? Let's go ahead and calculate this. This is going to be 20,000 thirds minus, what is this? We got to square the top and bottom. So that fraction there, that squared is that, right? So 10,000, oh, sorry, multiply it by 3, negative 3. So negative 30,000 over, oh, why did I put 4 here? Yeah, that's a 9. Over 9, like that. What is it at the end of the day here? Multiply top minus 60. 20,000 over 3 plus 30,000 over 9. I know you want to do decimals really bad right now, but I'm not doing it.
You don't have to be decimals. It ends up being 30,000 divided by 9 because you have to get a low common denominator.
Yeah, so our common denominator here is 9, right? So 3 on top and bottom. So 60,000 over 9 plus 30,000 over 9, which is what?
It ends up being 90,000.
90,000 over 9. 90,000 over 9, which is just 10,000. Did anyone do it on a calculator and get 10,000? No? What?
10,000 over 3.
Yeah, I got 10,000.
What did I?
100 over 3 squared,
Yes?
and then times -3.
I thought that was this.
Yeah, but the 9.
It shouldn't have been a 9, it should have been a 3, and then times 3.
It should be.
Yeah, but I did the -3 on top, which gives me that. And then this squared is 9 here. That's right. Common denominator? Well, you know what? I mean, there's no sense in us talking about it. Let's just graph it. Shit. Right? I mean, we can do that pretty easily. What was the original function? 200x, right? Minus 3x squared. And we are doing this on the interval 0, less than or equal to x, less than or equal to 200 over 3?
But it's, you have the x line.
Yeah. Jeez. I hate that part of that aspect of this program. 0 less than or equal to x, less than or equal to 200 over 3. What happened? What's going on? Do y'all see anything wrong with that? I think it's my window here. It's just messed up. That's the thing. Oh, there it is. I'm going to have to change this window. Let's go 0 to x. The biggest x we said, let's just go 300 here. And the y, I'm going to go from 0 to 20,000. There we go. There's our graph. Okay? Do y'all see that? There's the graph of our function. Let's see what that point is on the top. So we knew it was 100 over 3, right? That's where our critical number was. Then we plug that into the original function. I got 10,000. Going to need to be taken out and beaten down with a stick for that one. It should be 3,333. Yeah, you know what? I don't care, honestly. I mean, I don't. It's just plugging that number in, and the main elements are that we found the critical number, right? So what this tells me is that, when we were doing this and we start off, we said this was 4 and this was something, we got a certain area. And then we said, oh, we could have done it with a 10 here and we get a different area. The best way to do this, to get the most area, the best way is to make it like this. Make this 100 over 3, or if you like, 33.33. And then what would y have to be? So where do you get y from? Where are we going to get y from? Do you remember in the beginning we had this equation for y? Go back and look in your notes. I solved for y at some point. 200 minus 3x, right? That's our equation. So now replace x with 100 over 3. Threes cancel, and you just get 100. So you want this to be 100. So that's it right there.
That only gives us 300 feet of perimeter.
No, this is 33. This is 33.33333.
Yeah, because it's times 6 is
Times 6 is 200 plus 100.
Plus
Oh,
100
plus
plus
200, got it.
Plus, oh, the 100 there. Oh, okay, you were talking about the perimeter, the total number, the fence. I thought you were talking about the area.
No, I was talking about that.
So this is the way we build the pen. This is the way we build the enclosure so that we get the most area out of our fence. That's the way you do it. All right? Okay, sorry about that messed up 10,000. Like I said, you can go back through and do that. I'm sure you can come up with 3,333.333. Maybe I'll go back and look at where I made a mistake, but. So what do you think? I mean, do you see how you might use something like that? I'll give you another problem, but we're not going to do it, just to get you thinking about like what you could actually do with this. Let's say that, let's say you have a major highway. So you got traffic going here, you got traffic going here, you know, like a major interstate, 1604, you know, both directions traffic. Now let's say that you have some building over here, building A, and then let's say you have some building B over here. And let's say you need to have a secure hardwire connection between those two buildings. Some sort of like network cable or something like that. Fiber optic, something like that, you know, right? Fiber optic, let's just say fiber optic. So when you do this, let me tell you how far these buildings are from one another. Let's say that's 2 miles. And we're going to assume this is straight for now, okay? So you go to a company and you say, hey, we'd like to get some bids on running fiber optic cable from A to B. Understand? So let's say we work for the company. Well, one way we could do it would be to go underground and just dig straight from A to B. But it's very expensive to go underground, right? It's easier for us to put the cable up on a pole or something like that, okay? Maybe you don't put fiber optic on poles, I don't care. The idea is this though. We can go the entire way this way, above ground. Let's do above ground in a certain color. Let's say we do above ground like this, but at some point we will have to dig, right? You can't have anything over the highway. That's part of the problem. And then we could do that, right? So we would have, this blue cost would be cheaper because we're just running it from pole to pole. The red cost would be more expensive. So I need to make up some numbers for the cost. Let's just say that running the above ground, and I have no idea how much this really is. I'm just going to make up some numbers. How much per mile you think? Like that includes, we're the company, right? That's we have to pay the workers, the equipment, everything. To put 1 mile of cable above, we provide the cable, everything. What do you want to charge? A mile, per mile? $100? No, this is America. This is America. No, no. What do you think is more realistic? I'm thinking close to like 100,000 is what I'm thinking. Maybe let's compromise. Let's go with 50,000. Okay. Per mile. That's expensive. Do you have a more accurate number? You think?
Say maybe 20 or...
Okay, we'll go with 25. Yeah, that might be a little excessive. All right. Okay, so 25,000 per mile to run it above ground. Then the red, which is below ground. Now, what are we talking here? You want to go with 100,000 a mile?
Wait, but how far is that?
Yeah, we should talk about how, let's make a distance. We have to have this distance. Let's say the distance from here to here, just for making it difficult, 0.75 miles. Okay? Right, so how much do you want it to be? 100,000, let's go with that. So 4 times as expensive. So here's the engineer that never took calculus. Well, I shouldn't do that. It's 2019, right? 2019, I'm on video. Like, that is dangerous right there. Okay. So the engineer without calculus says simply, look, it's most expensive to go underground, so let's do, this would be the shortest distance underground that we could go. Go all the way down and go straight across, right? That's the shortest red we're ever going to get. Let's do it that way. Right? Yeah, do you agree? That is an approach. And then you're going to have another person who comes in, you know, the intern is going to be like, no, just shortest distance between 2 points is a straight line. Let's just go all underground. Right? Well, that's super expensive. It's the shortest distance, but it's the most expensive. And then you have you, right? That's taking calculus. And you say, no, no, no. What we need to do is figure out, what we need to do is figure out, the most efficient way to go. So what we're going to do is this. We're going to say, imagine we go out down the road to some point X. And then from that point X, we cut across to B. We're going to find a function that would give us the cost of doing that. And then we're going to find the minimum of that function. Does that make sense? So what would this cost function look like? What would the cost of this be? Well, let's see. I go how far here? X, and how much am I going to pay to go that far? This is in miles. So 25,000, right? Times X. So if X is 2, right? That puts me out here, right? And then plus, now I need the cost to go underground. And that's going to be this distance right here, which we can call Y, right? So 100,000 times Y. Y'all still following me? I said I was just going to show you, but now it looks like we're doing it. Okay, so now this cost function depends on 2 variables. We need to see if we can eliminate one of these variables. So what I'm going to do is try and get rid of the Y. And do you see the geometry in here? Look at this geometry. Right there. We have a right triangle. This is Y, isn't it? Okay, do you know this side? 0.75. Do you know this side? Oh, yes, you do. You know it in terms of X. 2 minus X. Okay, 2 minus X. Because if this is 2 and you've gone X, then this is 2 minus X. This is what's left. Now, do you have anything that you can think of that would somehow relate these sides together that would create an equation that had X and Y in it? Pythagorean, right? So I'm going to go over here, do it. I'm running out of room. I know that 2 minus X squared plus Y squared must equal 0.75 squared, right? Can you solve this for Y? Can you solve that for Y? Yes? Y squared equals 0.75 squared minus 2 minus X squared. So just bring that over. And then one last step, square root. So Y is equal to the square root of 0.75 squared minus 2 minus X squared. Got it or no? And it has to be positive. That's why I'm not looking at the negative. So now look at what our cost function becomes. Our cost function is now a function of X, right? And it is 25,000 X plus 100,000 And then square root of 0.75 squared minus 2 minus x, that quantity squared. There we go. That's our cost function. And we want to know its minimum value. Minimum, not maximum, right? Maximum if you really want to make some money, right? Minimum if you're trying to get the bid, right? So do we have a closed interval? Yes. What's our closed interval? X must be between 2. 2 would be the engineer who said, hey, look, that's the least amount of red, right? That'd be go x is 2 and over. What would this lower one be? 0, which means that would be the intern who said, hey, don't go anywhere that way, just go underground, shortest distance. Do you see that the 2 endpoints take care of both of those scenarios? And we are trying to figure out if there's something better in between, right? Now, I don't feel like taking the derivative of that right now, but I have a computer. And really, like in the real world, the part that I just did is the part the computer can't do. That's the part you do. Once you get it to there, that's when the computers come in. Does that make sense? Okay, so now I'm going to do this. 25,000 x plus the square root of 0.75 squared, I'm excited about this one, minus 2 minus x squared.
And then 100,000.
Oh, yeah, I forgot the 100,000 way out there. Okay, I don't see the graph anywhere, which means this is expensive. No? Why is it not showing up? Oh, I see it up there. Okay, so I need to close my window out. I need to close my window out a little bit. Right now my x is too big, so I'm going to go between 0 and 2, right? That was my x. And let's just see if it comes up. Obviously, it's not coming up there. So let me see if I can start putting in 1, 0, 0, 0, 0, 0. Oh, there it is. Do you see it down there? Oh. Wow. That is pretty cool. I'm going to zoom in a little bit. Looks like 200,000. Check out that cost function. It's beautiful, isn't it? So both of those, the engineer that didn't have calculus needs to go back to school, and the intern needs to learn from this that calculus is important, all right? Because, man, does that even look right? 2 minus x, quantity squared. Looks like we have a local maximum, or it looks like we have a global max somewhere in here, right? But this doesn't look right. Did I type it in right? 25,000, 100,000, 0.75 squared minus 2, right? X was between 0 and 2. Do y'all see why I'm kind of concerned about this picture?
But that's outside the...
Yeah, this is outside the thing. Yeah, let me put our range in here. 0 less than or equal to, x less than or equal to 2. There we go, okay. Yeah, but I still don't like this. We should have a graph over here, because there is a cost of just going underground the whole way.
But you wouldn't go more than 0.75.
Yeah. Yeah, the x would have to be 0. Okay, well, we trust it. What does this tell you? The max is at 2, which means the minimum is where? The max is at 2. That means the engineer that said go all the way down and then across is going to actually cost the most amount of money. It appears here, and I'll double check this after class and I'll send you all an email. I'll double check to make sure all the math is good here, because I just made this problem up and I don't think I made any mistakes, but it appears here that our minimum is where? 1.25. 1.25. X is 1.25. And what was the value there? 31,000. This something's wrong.
I mean, technically 1.1.
Something's wrong.
Because it was 25,000 per mile, so 1.25 doesn't make sense.
Yeah, but we have to go underground. Yeah, maybe. See, this is. Can I just draw it real quick again? I don't want to leave this unsettled. Okay, we have 2 here, point, and then this right here. I'm going to go 3/4, and we went out to x here. We came across here, called that y. This distance right here is 2 minus x. Okay, so 2 minus x, y, 3/4, solving. Yeah. I see it. Do you see it? What did I write down for my equation? Y squared plus 2 minus x squared equals 0.75 squared. That's what I wrote down. What's wrong with that? I did hypotenuse squared plus side squared is this squared. It's this squared plus this squared is this squared. Did someone catch that earlier? Not say it? No? Okay, well, what does that change? Quite a bit. That means that this would have been y squared equals 2 minus x squared plus 0.75 squared. So it's actually a little bit nicer because this goes underneath the root. So that's all that changes. This right here is underneath the root. So I'm just going to go tweak it. See, I knew something was wrong. Just change that to a plus. Now that looks a little bit better. Yeah, see? Now it makes sense between 0 and 2. Do y'all understand what I did wrong? Okay. So the engineer needs to go back to school. The intern needs to learn from this, and the engineer needs to make sure he doesn't take Di Giovanni at Northwest. No, I'm just kidding. Okay, so look, we've got this right here and this right here appear to be our max and min. All right? So the maximum would have been right there, and it would have been $213,600.09.
And that's if you go straight across.
And that would be if x was 0, which means you just go straight underground the whole way. That's the intern, okay? Saying, okay, that'll cost us the most amount. And then you have I don't know, is the engineer right? I can't tell here. What's the value there? Look at the cost here. 122,618, right? Right there, but what about the endpoint? $125,000, right? Do y'all see that? Wow, this worked. This worked. I was hoping it would work like this. If you can ignore my mistake, then maybe you can appreciate this. The optimum solution is right there, not right here. And look at the difference in cost. So to go out 1.86 miles, if you go out 1.86 miles and then cut across like there, that would be the cheapest way to do it. Now, it's not that much cheaper though. It's like, this is 122,600, and if you don't dig, it's 125,000, right? So, you know, I don't know, if I were the owner of that company, I'd say, we're going straight across and over, you know. But that's like, a couple of $1,000 difference. And if you're doing this, let's say, on a large scale, imagine you're doing like these highways that are being redone, right? And all these things have to be rerun. I mean, you can save hundreds of thousands of dollars for your company, right? So I hope that makes sense, that it can be applicable to the real world. You can even do it like with that fence problem we just did. What if you had 400 feet of fence, but like 200 feet of it was chain link fence and the other 200 feet was wrought iron fence, and they have different costs? Then how would you build it to get the least cost? Things like that. Okay, well, that's gonna wrap it up. We need to keep going, do more examples, because I did 2 word problems that I wasn't planning on doing. So see what you can do on the first few problems out of this section, which means I expect out of homework that you could pretty much handle everything up through like number 43 I wouldn't mess with, 45 I wouldn't mess with. So 43 and 45 don't mess with. 31, yeah, probably 31 through 36 I wouldn't mess with either. Y'all hear me? 31 through 36, don't mess with it. And anything past 41, don't do. We'll do some more complicated examples of having to take derivatives next class. This is 4.1. Just 4.1. So the quiz on Tuesday will be Thursday. Sorry, the quiz on Thursday will be over this section. Thursday. Yep. Now, but I'm going to basically what I'm going to do is I'm going to give you a function, ask you to find its absolute max and min. I'm going to give you a closed interval. That's it. But the function I give you is going to be very straightforward, very direct, because I can't afford to have you spending 30 minutes on it.
Will there be word problem?
No word problems. This is coming later. This is the section called optimization. I just kind of the preview turned into like too much today, but
Don't erase it yet.
I'm not going to erase it. Yes.
When we first started, you said that this point to this point is y,
Yes.
but it's not y.
Why is it not y? Oh no, it's not this y.
So how would you find that like distance? Because it would have
Oh,
to
okay.
be less than 0.75, right?
Yeah, so we have that equation. Well, when you set it up correctly, you have the equation. I didn't set it up correctly. Right?
Mm-hmm.
So when we set up the Pythagorean the correct way,
Oh, you would just plug the x into that.
that's right.
Okay.
Yep. So you have that, and now you know what x is, right? X was
Yeah.
whatever, 1.86. Plug it in here, plug it in, solve for y, and you'll get the y. That'll give you your hypotenuse. Yes, sir?
Do you remember the name of the black guy from the corner?
Don't. Well, yes, I do remember his name. Why?
I was going to message him so that he can prep for the quiz.
Oh, well, I'm not quite sure I can tell you people's names.
Oh, you don't want the...
Well, I mean, I don't think that I can share students' information with